In the savannas of Africa, honeybees conduct their daily operations with intricate precision, guided by one salient directive: survival. They harness the power of collective intelligence, where eusocial insects like bees, ants, and termites collaborate, creating synchronized colonies that can handle tasks far beyond the capability of an individual insect. Each member provides small but crucial bits of information to the group, enabling the colony as a whole to adapt and resolve challenges at hand. They exemplify unity, coordination, and a superior form of collective problem-solving approach prevalent in the natural world. This natural phenomenon provides an analogous strategy for battlefield operations, where decision-making, under highly dynamic and sometimes hostile conditions, can have far-reaching implications. A commander on the battlefield faces an existential dilemma: to make and execute decisions under intense pressure and in real time. The challenge is managing vast amounts of incomplete and rapidly changing data and concurrently, to outmaneuver the adversaries. However, by leveraging the principle of swarm intelligence, applying a digital mirror to bees, ants, or termites, a commander can decentralize decision-making, reduce the processing burden, and accelerate responsiveness. In the next frames, we will explore some natural use cases for this technology. The first use case is distributed attacks. Swarming drones can execute synchronized attacks on enemy targets, overwhelming defenses and maximizing the chances of mission success. The coordination between the drones and the swarm allows for complex maneuvers and tactics that surpass the capabilities of individual units. The second use case is continuous surveillance and reconnaissance. Deploying a swarm of AI-based drones can provide round-the-clock surveillance, capturing continuous real-time intelligence from multiple vantage points. This will keep the commander updated with the evolving situation, providing a comprehensive spatial overview, and enabling effective tactical maneuvers. The third use case is logistics and supply delivery. In scenarios where ground transportation is treacherous or slow, using a swarm of drones could ensure fast delivery of critical supplies to troops. Additionally, these swarms can adapt to the volatile situations on the ground, altering their path and strategy in real time. The fourth use case is electronic warfare and cybersecurity. Swarming drones equipped with electronic warfare capabilities can disrupt enemy communication lines, causing disarray and confusion. These swarms can also act as a shield, countering enemy electronic warfare efforts by decentralizing the target. In the event that one drone is knocked out, operations may continue with other members from the swarm taking over the lost drone's responsibilities. And finally, damage assessment and rescue operations. In the aftermath of an attack, a swarm of AI drones can quickly assess the damage incurred and identify points of interest for rescue operations. By working collaboratively, a swift and collective response can thus be organized to salvage maximum assets and personnel. In conclusion, swarm intelligence, as seen in eusocial insects, is a powerful natural mechanism that the realm of artificial intelligence has a unique opportunity to capture. Implementing such an approach in military operations could redefine warfare, increasing efficiency while augmenting decision-making capabilities. Swarming AI-powered drones lightens the load on a commander's decision-making process by decentralizing the operation to a cooperative multitude of autonomous units. Each drone, akin to an insect in a swarm, contributes to the overall mission objective dramatically by providing real-time data that helps adapt to rapidly changing battlefield scenarios. Critical tasks such as distributed attacks, surveillance, logistics supply, electronic warfare, damage assessment, and rescue operations can be revolutionized by employing such swarm tactics. However, deriving maximal advantage from this relatively nascent technology demands significant research and strategic planning. It also involves a careful ethical examination to ensure that the power of AI and swarm intelligence is used responsibly on the battlefield. A central ethical concern is the notion of human accountability and responsibility for life and death decisions. Traditional military operations have been governed by human judgment, where commanders and soldiers are held accountable for their actions on the battlefield. With the advent of AI-based robots capable of autonomous decision-making, questions arise about who should be held responsible in the event of unintended or unlawful consequences resulting from robot-led actions. Incorporating AI into military strategies necessitates clear guidelines for human oversight, intervention, and the establishment of a clear chain of responsibility. Ensuring that human operators retain control over critical decisions is essential in upholding ethical principles and maintaining compliance with international humanitarian law. By embracing technologies that simulate swarm intelligence, we can thus unravel a new chapter in military doctrine, one of collective intelligence, flexibility, and resilience. Just as a colony of honeybees operates seamlessly based on the contribution of every individual, a battlefield of the future might echo with the synchronized hum of countless drones, each playing its part in the grand design.